There are two things at work here. There's the algebra, and then there's the graph. Now, again, you can always graph, no matter what, depending on the equation, by using a table of values. You always can do that. But you should be noticing by now that there are a couple of things we can do to the equation that make it so we can graph it automatically without any table of values, without any real thinking about it. All right? And the first of these methods that you have seen is the slope-intercept form, which, if you look in your notes, you all remember is y equals mx plus b. M is the slope, and b is the y-intercept. So, if you can make that look like that, you're in business. All right? So, what I have highlighted in yellow looks similar to what is highlighted in blue, but it is definitely not the same, correct? What is different? I know it was a 4-day weekend, but somebody can spot something, some difference between what I highlighted in yellow and what I highlighted in blue. Excellent. In yellow, there is no coefficient for y, but there is in blue. Is there another difference? William. There's three terms here, isn't there? Right? But in this one, y is by itself. Excellent. That's the other difference. So, if I can make this blue guy, if I can get y by itself and with no coefficient in front of it, will it look like this? It will. So we take this and we simply do our algebra. 2x plus 3y minus 4 equals 0. If I want y to be to be by itself, then I should get rid of that 2 and get rid of that 4, shouldn't I? How do I get rid of this 2? Right now it's a positive 2x. What would I do to get rid of it? No, that's to get rid of the 2. I want to get rid of the whole thing. Right now I have positive 2x's here. How would I would do negative 2x's. Why did I draw this arrow? Because that's a shortcut that if you know what you're doing in math, you get to do that. If you need to move anything over the equal sign, you simply change its sign. So if I'm going to move that positive 2x over here, I'm going to get negative 2x. So when I move that negative 4 over here, if I really want to move it, technically I'm adding 4 here, right? Which means I'm adding 4 to this side. But the shortcut, I'm just moving it over plus 4. And that equals 3y. Now, we have, William noticed, we need 2 terms and 1 term. Have we achieved what William wanted to do? Absolutely we have. Have we achieved what Wong wanted to do yet? No, because y is still yucky. Right? How do I get rid of that? Now, Evan, I don't want to get rid of the y. I just want to get rid of the 3. So what do? I divide by 3. Y equals negative 2 over 3x plus 4 over 3. Now, does that look like that? Yes. What is that? That's my slope. What is that? That's my y-intercept. Why does that y-intercept scare you? Because it's a fraction. But who's in charge of this graph, Ryan? You are. So you make it so it doesn't have to scare you. 1, 2, 3. What number should I write right there? 1. Now my graph is going up by thirds, isn't it? And I need to go up to 4 thirds, don't I? 1, 2, 3, 4 thirds. Now, what if I go 1, 2, 3? What number should I put there? 1. Now, every square is worth a third, isn't it? And what is my slope? Negative 2 thirds, correct? Slope is also rise over run, right? So how do I get a negative rise from there? Down how far? 2, and then which over? That way or this way? That way? Which is that way? The other right. No, he's right. Right. 1, 2, 3. Now, what else must I do to make sure it's a straight line? Go back to where I started and do what? Do the opposite. Up 2 and left. I went 4. And there is the line. Without any tables of values, no problem. The only thing I showed you there that you didn't already know was this little shortcut, and most of you probably already knew it. Is everybody cool? Should fractions bother you? No, because we can change the graph to work with them, right? What if this was 1 over 6? Then what would I use? I'd go up in 6. 1, 2, 3, 4, 5, 6, and that would be where 1 is. Everybody cool? All right. Next one. This one says I'm supposed to use the intercepts. What do I know about every single x-intercept? That it is 0, y. What do I know about every single y-intercept? X, 0. That's an x, that's a y, that's an x, that's a y. What do you see there and there? X's and y's. Fill them in. When x is 0, what's going to happen to 5 times 0? What's going to happen?
0.
It's going to disappear. So I would have negative 10y plus 15 equals 0. Do I want negative 10y's or do I want 1y? I want 1y. So negative 10y equals negative 15. Y equals positive 1.5. Everyone agree? If I have y as positive 1.5, what can I write right there? 1.5. Because y is 1.5, there's a missing y. So I have 1 point on my graph at 0, 1.5. Should I put it on the graph yet? Why not, Root Joe? You don't know the y. I might need to change the scale. I mean, you don't know the x. We might need to change the scale. So we're going to wait a second, aren't we? All right. Well, now our y is 0. So what is going to happen to this y now? It's going to disappear, and I'm going to have 5x plus 15 equals 0. 5x equals negative 15. X equals negative 3. If x is negative 3 there, what's that x? He waited patiently. Still waiting. Maybe someone will understand that when x equals negative 3 and I see an x, I can do something. Thank you, Avery. If only everybody else could follow that simple line of thought. So I have another point there. Now, am I in trouble? What makes this difficult? It's a 0.5. Who's in charge? You are. You need that 0.5 to be where? On the y or the x scale? On the y. So I need to go up by halves here, don't I? 1, 2. There's 1. 3, 4. There's 2. Where's 1.5? Right in the middle. Now, if I've done that on the y scale, I should do it on the x scale, right? I should try and keep it the same. Can I? -1, 1, 2, -2, 1, 2, -3. Does it fit? So I can do that. And there's my graph. Everybody good? Now, Mr. Myers, you see you should always use 3 points. All right. 1, 2, 3, 4, 5, 6, 1, 2, 3. So 1, 2, 3, 1, 2, 3, 4, 5, 6. There's my third dot, and there's my line. Good? Lovely. Before I go on to the next question, I would like to take a moment to take the temperature of the class. What I mean by that is everybody comfortable with the very simple fact that every equation we deal with has an x and a y. And every graph we deal with is made up of x's and y's. So if there's a dot anywhere on this line, that dot has an x and a y, doesn't it? And where could those numbers go? Where could I put those numbers? Whatever they are, where can they go? See, this is why I am doing this, because apparently not one person can tell me this. Fortunately, I have until 10:25 to sit here and wait for this answer. That's only 45 more minutes. I got time.
What was the question?
The question, Wong, is any dot on this line has x and y, right?
Yeah.
What can I do with those two numbers if I know the equation?
Put on the equation.
I can put them into the equation, no matter what they are. What if I told you I wanted to know if that dot was going to be on that line? What would you do? This line has not been graphed. I tell you that dot. What is that dot's coordinates? I'll zoom in just in case. What is that red dot's coordinates? Pardon me? 7, 2. What letter is that 7 represent? X. What letter does that 2 represent? Y. The equation was 5x minus 10y plus 15 equals 0. What can I put right there? 7. Minus 10. What can I put right there? 2. Plus 15 equals 0. What's 5 times 7?
45.
Minus 10 times 2.
20.
20 plus 15. Is 35 minus 20 plus 15 0?
No.
No. So is that dot on that line?
No.
No. The conceptual point that you need to understand is the x values can go into the equation where you see an x. The y values can go into the equation where you see a y. Can I make that any simpler for anybody? Does everyone understand that?
Yeah.
Okay. Find the slope. Do you have a graph?
No.
So can you count?
No.
No. What do you got to use? y2 minus y1 over x2 minus x1. Which is surprising because every single one of you knows how to do this, but nobody could answer this when I asked over here. What is this value right here? X. You want to make it x2? That's fine. What does that make the 3?
Y2.
What is this?
X1.
X1. What is this?
Y1.
Y1. Where do those values go? Into the equation. So why did everybody have so much trouble telling me this one? Aren't those x's and y's? Aren't those x's and y's? So what was complicated? Aren't those x2s and y2s and x1s and y1s? Aren't those y2s and y1s and x2s and x1s? Do you know how to put those into here?
Yeah.
So do you know how to put those into here? Yes. So the next time I should not wait 3 minutes for somebody to answer that question, should I? What's y2? 3 minus, what's y1?
4.
4 over, what's x2?
Negative.
Or negative 10 minus, what's x1?
2.
2. What's 3 minus 4?
Negative 1.
Negative 1. What's negative 10 minus 2?
Negative 12.
Negative 12. Two negatives make a
Positive.
positive slope, 1/12. All of you should have been able to do that. Number 4. I need the slope of a line parallel to this. If the line is parallel, what is its slope?
Same.
The same. What is this line's slope? How will you find it?
Make it Y.
You can make it y equals mx plus b. Because if y is isolated, then x's coefficient is what? X's coefficient is m. And m is what? What is m? The slope. So if I know what m is, and I know I need a parallel slope, I just need the same slope, don't I? So how do I get this to look like this? What do I have to do to y? What do I have to do to y to make it look like this? He waited patiently. Pardon me? If I move that y over there, I then have 5x equals 3y. Am I getting close? Do I care about the 12? No, because I only care about slope because it's parallel, right? So the 12 doesn't even matter. I just got to get y by itself because whatever's with x is my slope. Now what must I do to make this look like this? Divide by 3. 5/3 x. That's this line's slope. So every other line that is parallel to that has what slope? What does parallel mean for slopes? They're the same. So the slope of any line that is parallel to this is what? Is the same, 5/3. What if it's perpendicular? What does that mean for a slope? It's got to be opposite and reciprocal. So the first thing I need to do is find the slope I have. How do I find this slope? I need it in this form. First of all, do I care about the b? No. So do I care about the 10?
No.
No. I only care about the x's and y's. Once y is by itself, do I know my slope? Great. How do I get y by itself? I move the y, and then I have to divide, right? Now, if I move what should I move? The y or the 7? I need y by itself. Does it matter which one I move? No. I'm going to move 7 because I want y to stay positive. Because isn't y positive right there?
Yeah.
Great. So 2y equals negative 7x. Now what do? I need y by itself. Divide by 2. So y equals negative 7 over 2x. That's the slope I have. Is that the slope I want?
No.
No, because I need perpendicular. So what do I have to do to that slope? Opposite. So right now it's negative, so it must be. And I reciprocate. It's right now 7/2, so what does it become? 2/7. And that's done. Well, that wasn't a pain. Assembly or pep rally is in 35 minutes. Did you guys have 6 and 7?
Yeah.
Good. All right. This is when you actually have to apply stuff. What letter does that represent? X. Well done, Ryan. What letter does that represent?
Y.
Y. What letter does slope represent?
M.
M. Do I have any form that uses M, X, and Y? Have I done any math with any equation that has an M, an X, and a Y? What? Oh, sorry. Y equals mx plus b, correct?
Yeah.
What can I write right there?
Negative.
-2 equals. What can I write right there?
Negative 2 over 3.
What can I write right there?
Negative 5. Negative 5.
Plus what?
B.
B. What should I do to find out what b is?
Solve this equation.
I do math. What is -2 thirds times -5?
10 over 3.
10 thirds plus b, correct? 10 thirds is 3 1/3, correct? Everyone agree? What do I do to get b by itself? What do I have to do with this 3 1/3? Minus 3 1/3. Where else? -2. -2 minus 3 1/3. What's -2 minus 3? -5. And then another third. -5 1/3 equals b, correct? So now, if that equals b, what can I write right there?
Negative 5.
-5 1/3. So I have y equals -2 thirds x minus 5 1/3, correct? And I want any other point. What do we know about every single other point? What is it? It is an x and it is a y, correct? Okay. What do you see right there? Is x input or output? Input. Who chooses inputs? You do. What's the easiest input to put in for x? 1. 0. What's 0 times 2/3?
0.
0. So when x is 0, what's y? -5 and 1/3. Is that an x?
Yeah.
Is that a y?
Yeah.
Do I need an x?
Yeah.
Do I need a y?
Yeah.
0 and 5 and 1/3. Negative. Negative. And that would be done. And finally, is that a right triangle? If it's a right triangle, what does that mean that two sides do? No. In a right triangle, two sides have to meet at what angle?
Perpendicular.
At a perpendicular angle, which means the slopes are opposite reciprocated, right? Do I want to check all three corners?
No.
Of course not. That's a pain. I want to only check one corner. So what should I do?
Make a plan.
I should sketch it, shouldn't I? Where is -4 or 4, -2? And then where? Down 1, 2. There's A. Where is 2, 1? 2 and up 1. There's B. Where is -2, -2? There's C. What is the only possible 90 degree? Just say the letter.
Angle
B is the only possible 90 degree, right? So if I check that slope and I check that slope, do I know if they're perpendicular?
Yeah.
Great. Can I count this on the graph because I made the graph? Can I count this? Or could I do y2, y1? Who makes that choice? You do. If you're going to count it, how far up did I go from C to B? 1, 2, 3. Up 3, right? How far that way did I go? 1, 2, 3, 4. So C to B is 3/4, right? That's the red one. The blue one, how far up did I go? 1, 2, 3. How far that way did I go? -2. 3 over -2. Are those opposite reciprocals?
No.
No. So is this a 90-degree triangle?
No.
No. Is everybody good? You'll notice I did not check homework. There's a reason. Everyone is cool? Without incriminating yourself, because I know the vast majority of you did not finish those 7 questions, do you understand what we have done? What is the only thing that you need to be aware of when you are doing this whole unit? X's, Y's. Every dot is an X and is a Y. And every dot lives on a line. X for X, Y for Y. No matter how I write the equation. If I write 5x plus 7y equals 32, X and Y can go in there. Right? If I write 3/4 X plus 1.75y equals 79, X and Y can go in there. That's all you need to bring to the party to do this entire unit. Math's always a party, Elijah. You can't have a party without math. How are you going to know how much pizza to order? Right? How are you going to know how much room you need? Right? How are you going to know how long it's going to take for the cops to get there to bust it when your neighbors call in if you don't do math? Picking up what I'm putting down? Can't have a party without good math. Which means, conversely, math must equal a good party. See what I did there? That's good solid logic. I had a great weekend. All right. Let's see. What do we got? 9:58. We're out of here in 25 minutes. We'll go over the test tomorrow. Everybody turn to page 198. On page 198, you see my favorite form. If I were to ask you to graph an equation, you now have 3 ways you could do it. Yes? Right? 1, you could make a table of values. Right? You could go X, Y. Where would you put numbers in for you on the X or the Y side? Which is input? X. So you would choose numbers here. Down the X side. You could do that, right? And then you would get some X and Y's. You could put them on a graph. What's a second way you could do it? It's the very first thing we did in this unit. We found 2 things. What did we find? Very first thing we did in this unit. X intercepts and Y intercepts. And what do we know about X and Y intercepts? X comma 0 and 0 comma Y. Pink with pink. Then I taught you a third method. What was that? You were able to find 1 point on the graph and then count from there. What was that one? Slope intercept. Y equals mx plus b. Right? B equals the y-intercept. And m equals the slope. Purple with purple. Everybody can do all 3 of those a little bit, yes? Okay. Notice that 2 of them use the y-intercept, don't they? And this first one, if you were going to choose a number to put in for x, what's the easiest number to put in for x? 0. So then x disappears, right? So all of these 3 are using intercepts, aren't they? The fourth method, the number 4, is the point, what we have here, point slope form. And point slope form uses any point, not just an intercept. Okay? I'm going to write it out right now. You should too. Does that look familiar to you? What do you see in that green form that you are already comfortable with using? You see y and x and m. Everybody cool? All right. Here is how this one works. That point, whatever those numbers are, that point is the starting point. Everybody understand? Just like in y equals mx plus b, we started at the y-intercept, right? Well, in this case, we start at that point. Everybody cool? Everybody understand? So, if I gave you any point on the graph, if I told you, somebody give me a number between 1 and 10. 5, give me another one. 7. There's a point on the graph, right? If I told you that point is on this line, where would I put the 5 and the 7? This is the starting point. We know that point's on the graph. So does it go in for y or y1? y1, because we know that's where we're starting. So it would be y minus what? 7, because y's are the second one, right? Equals m x what? Minus 5. Everybody cool? Now, if I told you the slope, could we put it in there? We could. What if I told you that the point we were starting at was -3, 4? Then it would be y what? Y minus 4, no brackets, sorry, equals m, then what? X minus 3, which would be what? X plus 3. What if I told you that it was 3 minus 7? What would it be? Y minus 7, which would be? Y plus 7 equaled m, then what? X minus 3. Does everybody see? What do you notice about all of these points when you compare them to the points that I started from? How does the actual point on the graph compare with what the point looks like in the equation? I know that 1 out of 28 of you sees this connection. In the equation, what was written? Positive or negative 5? In the equation, negative 5. What was the actual point on the graph? In the actual equation, what was written? Negative 7. What was the actual point on the graph? When the equation was positive 3, what was the actual point on the graph? Negative 3. When the equation was negative 4, what was the actual point on the graph? Positive 4. Does everybody understand? As always, I like to show you why that works. You don't need to write this down, what I'm about to show you, but you might want to write this down. The actual point on the graph has the opposite sign to the equation. And you may want to highlight opposite. Now, as always, I like to show you why something works, even though most of you don't care, but I like to show it. Helps me out. Somebody give me a slope, any slope. Everybody cool? Now, if I told you, let's pretend we didn't know point-slope form. We've never seen it before. And I asked you, is 5, 7 on this line? So we already know 5, 7 is going to be on the line because I've showed it to you, right? But let's pretend I hadn't. Where would that go now? For x. So I would have y minus equals 3 halves x minus, sorry, not x, not y, minus 7 minus 5. What would go in for the y and the x right now? 5 and 7, correct? 7 minus 7 is what? 0 equals. 5 minus 5 is what? Is 3 halves times 0, 0? Does 0 equal 0?
Yes.
So 5, 7 is on this line. And we already know that because I gave you the shortcut. The points are just opposite. Is everybody good? So let's see if everyone is good. What do you know about this line? You know 2 things about it. What do you know? What do you know about that line? There's a slope of what? Negative 2/3, and it goes through what point?
One negative.
Goes through 1, negative 2. What do you know about the next line?
Negative.
And what point does it go through? Negative 3 and positive 4. What do you know about 3? Hey, wait a minute, Mr. Myers, you're tricking me. This isn't written this way. What if I put those brackets there? What number is always in front? So what's my slope? 1. And at what point does it go through? Negative 2, negative 1. Number 4. Mr. Myers, you're messing with this again. There's no point over here. So it's the same as y minus what? 0. What's the slope? 1/2. And what does it go through? Negative 4 and 0. Because there's nothing with y. What's the slope in 5? Negative 1. What point does it go through? What's the slope in 6? What does it go through?
1 and 10.
Can everybody do this? Good. Turn the page over. What form is that? Point slope form. We just learned it, correct? Point slope form, once again. You know that x1 and y1 is a point on the graph. Except you have to remember something. Point on the graph with what? What do I have to remember about those signs? With opposite sign. And you know that m equals what? slope. So, there and there are my starting points, correct? But it's not 1 and negative 2. What is it really? Negative 1 and positive 2. Where is that on the graph? Left 1, up 2. Now, you have a starting point. How do you make enough points to draw a line from the starting point? I use the slope. Slope is 2/3, which is also rise over run. How do I do a rise of 2? Up 2. How do I do a run of 3? Right. 1, 2, 3. And to make sure, go back to the starting point and do the opposite. So I go down 2 and left 1, 2, 3. And I draw my line. Everybody should be able to do it, right? Great. Do 8. What's my starting point?
Oh, no. Yeah, no,
Negative 5 and negative 1. Sorry, I was looking at the slope. So now what do I do with that and my graph? Put it on there. 1, 2, 3, 4, 5, down 1. How do I get 2 more points? I use the slope. Slope is negative 2. But I need a rise and a run. Negative 2 over 1 is rise over run. How do I do a rise of negative 2? Down 2. How do I do a run of positive 1? To the right 1. I need 3 points to be sure, so I go back to the starting point and I go if I went down 2 and right 1, where do I go from here? Up 2 and left 1. And there's my line. Can everybody do it? Great. Now you got to put it all together. Read this question. Tell me every word that's important. Read it to yourself and think about it. There is quite a bit of important information in that question. Tell me what there is. Give me one of the hint words from that question. Perpendicular, right? So that means I've got line 1 and line 2, and we know that they are perpendicular. That tells me something, yes? If I know one slope, do I automatically know the other? How? Opposite reciprocate. Great. Do I know anything about either one of those lines? I know one of those lines, don't I? I know everything I need to know about one of those lines because I have its equation, don't I? Right? So what do I know about that guy? I'm going to call him line 1. 2x minus y plus 8 equals 0. Can I put that on the graph? What's the easiest way to put that on the graph? You've got 4 methods. Think of one. Yeah, this is almost in y equals mx plus b form, isn't it?
Yeah.
If y was by itself, I could graph it, couldn't I? Is y almost by itself? What would happen if I moved y over there? Would it be by itself?
Yes.
And I would have 2x plus 8 equals y. Can I put that on the graph? Where? Where do I go? What's my starting point in this form? He waited patiently. Up 8. 1, 2, 3, 4, 5, 6, 7, 8. What's my slope? 2. How do I do slope? Rise over run. So down 2, left 1. And there's my line, correct? What do I know about line 2? Line 2 does something with line 1. What does it do? What do they do? They cross at the y-axis. So if line 1 hits the y-axis there, where does line 2 hit the y-axis? In the same spot, correct? And I know line 2's slope, don't I? What is it? Negative 1/2. So, I know that line 2, y equals mx plus b. Do I know the slope? What is it? Negative 1/2. X. Do I know the y-intercept? Why is it 8, Avery? Because it has to cross at the same spot, doesn't it? Plus 8. Can I now graph the blue line, line 2? Where do I start? At 8, and how do I graph it? Down 1, right 2. And I should have 3 dots, right? So up 1, left 2. There's my line. And we know that that's 90 degrees. Now please notice, we needed stuff from every single lesson, didn't we? We needed slope. That was the very, very first lesson. We needed slope-intercept. We made this line in slope-intercept form using our grade 6 algebra, yeah? Perpendicular, that was from lesson 3. Everybody good? All right. The pep rally will be in 4 minutes. Tonight, try page 200. The questions go all the way to page 202, and then the answers start. We'll go over your test tomorrow when, hopefully by then, Mr. Endozo will have come and seen me to write it. No, it is not a cumulative. Kevin still owes me Unit 5. If he doesn't show up to write it today at lunch, he'll be writing it tomorrow in class.
I'll write it tomorrow.
Great.